This is Geometry Unit 1, Lesson 2, Constructing Patterns. So we're starting out with two circles. It says the centers are point A and point B. So here's my circle. We call that circle A. And here's my circle B, right? We name them by their centers. Okay, so then it says, based on the diagram, explain how you know each statement is true. So we have a few statements here. I'm going to be kind of scrolling back and forth so we can see the diagram, and then I'll come down and type the explanation. So the first one says the length of segment EA is equal to the length of segment EB. So I'm going to look up at my diagram, segment EA. Let me see if I can highlight a little bit. There's EA, and then segment EB would be this segment right here. All right, so it does look like these two segments are in fact the same length as each other. We know that is true for sure, right? Because we can see that the two circles have the same radius. I can tell that they have the same radius because the radius for this circle, for circle A, goes from the center to a point on the edge, which is B right here. And when I look at my other circle, it goes from the center at B out to a point on the edge of the circle, which is A. So because the two circles share this radius AB, that means that the two circles are the same size. So any segments that we draw that would be a radius for the circles are going to be congruent to each other, right? So EA and EB have to be congruent for that reason. Okay, so my explanation, segment EA is a radius for circle A, segment EB is a radius for circle B. Because the two circles share the same radius, segment AB is a radius for both circles. Any segments that function as a radius will be congruent. All right, so moving on to our next statement. Triangle ABF is equilateral. So I'm going to come back up here. We're looking for triangle ABF. All right, so I'm going to try to use my highlighter again. A, went a little bit too far on that one. A, B, F. Here's our triangle. Okay, so we're explaining how we know that this highlighted triangle right here is an equilateral triangle. Well, it really comes from the same kind of explanation that we had for the previous statement, right? If the two circles are congruent and AB is a radius for both of those circles, well, look, AF is a radius for circle A, and FB is a radius for circle B. So I know that these two sides are going to have to be congruent to each other, right? Because they're radii for congruent circles. And AB is also a radius there, right? So because all three segments function as a radius for their congruent circles, they have to be congruent. All right, so all three segments AB, AF, and BF function as a radius for one or both of the congruent circles. Therefore, they must be congruent to each other. Equilateral triangles have three congruent sides, so triangle ABF must be an equilateral triangle. All right, our next statement says AB is equal to 1/3 of CD. So AB is equal to 1/3 of CD. Okay, so here is, I'm going to use my highlighter. Here is A, B, and here is C, D. Okay, so how do we know AB is 1/3 of the length of CD? Well, when I start looking at my circles again, right, I can tell that my segment CA, that's a radius for circle A. From A to B, that's a radius for circle A, right? So CA has to be congruent to AB. When I start looking at this other circle here, circle B, right? AB was a radius for circle B as well. And when I look at segment BD, from B to D is also a radius for circle B. So that means that AB has to be congruent to BD. Well, now I have three segments that I know have to be the same length. CA is the same length as AB, is the same length as BD. So if I'm just looking at one of those segments, AB, that's 1 out of 1, 2, 3 segments. So 1 out of 3 is 1/3. So AB is 1/3 of the length of CD. Okay, so CA and AB are both a radius for circle A. AB and BD are both a radius for circle B. That means CA is equal to AB is equal to BD. Because AB is 1 out of 3 equal segments, AB is 1/3 the length of CD. All right, moving on to our last statement that we're going to explain why it's true. We have CD equals DA. So coming back up here, CD equals DA. Let me clear off our grid a little bit, not our grid, but our diagram. Okay, so it was CD is equal to DA. All right, I'm going to highlight. Here is C, what was it? CD is equal to DA. Whoa. Okay, so this one's a typo. All right, this question is actually supposed to say CB is equal to DA, right? We can tell when we look from C to D is not the same as from D to A. Okay, so this one had an error in it. Okay, we're going to answer the question that's intended. It should be CB equals DA right here, and that's what we're explaining how we know is true. So CB is equal to DA. Coming back up here, well, when I look at CB, that's the diameter for circle A. And when I look at DA, that's the diameter for circle B. So if the two circles are congruent, then I know their diameters are also going to have to be congruent to each other. The two diameters are the same length. Otherwise, these two circles would not be congruent to each other. CB equals DA because CB is a diameter for circle A and DA is a diameter for circle B. The two circles are congruent to each other, so their diameters are the same length. Okay, and the next task, we're going to create your own diagram. You're going to record your instructions right here. I'm not going to do this one for you because I want you to create your own here. It says, as you make your pattern, record each move in the space below. Remember to try to use precise vocabulary so someone could make a perfect copy without seeing the original. Include instructions about how to shade or color your pattern if you decide to include coloring. All right, so take a few minutes. Please create your own pattern. You're going to type your instructions out here as precisely as you can. All right, once you've created your own design, I'm going to have you try to follow some directions to recreate a pattern. And so you can kind of see a couple of examples here. If you have ever visited a mosque, madrasa, man, I hope I'm saying that right, or other location where the religion of Islam is practiced, you may have noticed walls decorated with intricate geometric patterns. Throughout history, artists and craftspeople have developed these patterns, which are based on compass and straight edge constructions. So these fancy designs here are really just geometric constructions. Okay, so there's about a 1-minute tutorial right here where it's going to show you the instructions as you go. Feel free to pause it, rewind it as much as you need to there, and you're going to attempt to recreate the pattern down here.